Welcome back to the Cisco CCNP route training from Train Signal. Again, my name is Joe Reinhardt and I'm your instructor. We've dealt with OSPF basic configuration, design and planning, advanced configuration topics, and now what we want to do is we actually want to look a little bit at OSPF troubleshooting, some common issues, common problems, and things that you might encounter when dealing with this particular protocol. So in this particular lesson, the first thing we're going to look at is the troubleshooting model, just as we did with EIGRP. We'll look at some common issues and resolution steps specific to OSPF. We'll look at relevant debug and show commands, and then again we'll review, as we did with EIGRP, with dealing with Cisco TAC. So first, as we talked about before, you need a troubleshooting model whenever you're approaching network problems, because otherwise what you'll end up doing is chasing your tail, so to speak. You could run after a lot of different things, and without having a coherent strategy, you can end up confusing yourself more than actually solving the problem. So you see before you on this slide the steps that we've gone over before. Define the problem. You need to know what it is you're trying to solve, know what the behaviors that you're seeing in the network are, how particular devices are acting, and so forth. Gather your facts. What is the problem? What is not related to the problem? What could be unrelated? Try to make sure you have everything gathered on it, because if you're missing pieces of information, it can greatly change your finding the outcome. Document the facts. It's important to be able to make sure that you actually have a paper trail on this, so to speak. Make sure you have everything in order and together, and probably in a document that helps you with this. Consider the possibilities. What would be causing the particular symptoms that you're seeing? What could be the causes? There could be multiple causes. What different things could contribute to this particular thing happening? Based on that, create an action plan to address that specific possibility. Once you've done that, implement the action plan. Make sure you observe the results. Look and see if it's continuing, if it's solved, if it's some portion of it's solved. It could be multi-factor, in which case you may have solved one problem. If it doesn't work or completely resolve the problem, repeat until you have a resolution, and then finally, when all is said and done, document the solution, both for the sake of yourself and whoever may come to the organization while or after you were there. This is the graphic essentially describing the process we just talked about. You have a beginning point and an ending point. You have several decision points through the process, some steps, but this is a tried and true methodology that works for routing issues, switching issues, IP-specific issues, interface issues, and even advanced technology issues, security, unified communications, data center, and so forth. This is something that Cisco has long ago created, and it would be very helpful for you as a network professional to be able to use it in your everyday life and career. So now that we've looked at the troubleshooting model, or essentially reviewed what we've talked about previously, we want to look at common issues and resolution steps with the OSPF protocol. And generally they fall into the same three categories as they were with EIGRP. First is neighbor relationship issues, also routes missing from the table, and then finally address summarization problems. Now these are not exhaustive. These are the most common and broadly defined issues that you can run into, but there are other things as well. And it always is appropriate to be able to do additional research. So first, neighbor relationship problems, the first general category. So in this, there can be a number of things that go on, the first of which is that the neighbors are not establishing a relationship. And there are multiple potential causes for this. We'll go through each one. The first one is the desired interfaces have been configured as passive. In OSPF, just as it is in the other protocols, if you make an interface passive, you're not going to be able to establish a relationship on that interface. You can go into the particular device, do the show IP protocols command, and there will be an entry that says that it'll show for a passive interface. It's also possible that you can do a show running configuration and actually go through. You'll be looking for this particular entry under the OSPF routing process. So like for instance in our lab we have router OSPF 1. There will be an entry underneath that will say passive interface and then have a particular interface listed. If that's there, then you want to make sure that you delete that. If it's on an interface that's not going to be sending or receiving OSPF hellos and information, then it probably won't be harmful to do that. But you want to be able to make sure that you, on neighbor relationships that you want to have on specific interfaces, make sure the passive interface command is not there. Another potential cause is misconfigured neighbor authentication. I've run into this numerous times in different labs, and even in our lab there was at one point I had to double check my configuration. The easiest way to be able to tell this is, first, execute the show IP OSPF interface command, and it will tell you whether or not authentication is in use. In addition, you can also use the show running configuration command, and you need to look for the specific commands for authentication. The IP OSPF, and it's either going to be key for text-based authentication or message digest key for MD5-based authentication. You also want to make sure that the IP OSPF authentication or authentication message digest commands are in place. Those both have to be configured, present, and under the particular interface, and the strings have to be correct. If they happen to be missing, add either or both statements. And if the key is incorrect, make sure you change that as well. Another thing that can cause OSPF neighbors to fail forming adjacencies is different MTU values. If you recall, there are specific settings that have to match, the hello intervals and things of that nature, between OSPF neighbors in order to establish a relationship. The MTU value has to match as well. If it's 1500, for example, MTU size is just typical for Ethernet, it needs to be 1500 on the other side. If anything else, if there's any other value configured, you will get errors and it will not form a relationship. The easiest thing to do is do show interface. It's not a command that's specific to OSPF, but you do show interface. You'll be able to see the actual MTU size on that particular interface. Compare it on the one device, then compare it on the other. If for some reason they are not the same, you can manually change it using the IP MTU and then whatever the bytes are setting, for instance 1500 for an Ethernet. You can also set it to its defaults by doing no IP MTU, and then it'll take it back to command defaults. But either way, you need to make sure that the values match or you will not be able to form a neighbor relationship. Another very common cause, as it is with EIGRP, is you might not be using primary interface addressing to form the neighbor relationship. Remember, you have to have the primary interface IP address the same on both sides. If it's primary on one side and the other is secondary, it will not form. So the way to do that is to be able to do show IP interface and whatever the slot port syntax is for your particular platform, and verify that the primary IP address configured on the one neighbor and the primary IP address configured on the other neighbor do in fact match. And by match, same subnet, same mask. If you have one mask on one side and another mask on the other, you could have difficulties as well. If there's a problem with one not having the same primary IP address, change it, because only then will you be able to support and configure and form neighbor relationships. Another cause, a little less likely but still possible, is that somehow multicast traffic is being blocked between the devices. That's another cause for neighbor relationships not forming. It's easy to be able to do show IP interface, as we talked about before, and also show access list to see if any filtering has been configured. It could be common that you are in the process of configuring a lot of different things and you get to a particular spot. You may be trying to filter out specific types of packets, for example, and you remember the implicit deny any at the end of an access list, and if you don't specifically allow the 224.0.0.5 and 224.0.0.6, they'll be blocked. Remember the implicit deny any at the end of an access list. Also, you might want to look and see if the interface is in up state, as we've talked about before. If it's up-down or it's administratively down, it's obvious you're not going to be able to form a neighbor relationship because multicast traffic won't be able to go across either. So add the statements in an access list if that's the cause. If there's an up-down, investigate the cause of that, and you may need to replace an interface, device, a cable. It's amazing the number of times cables, how they fail. But that'll be something that'll be necessary for neighbor relationships to form across that particular interface. Another thing that can cause a failure in neighbor relationship formation is the network statement is misconfigured. The easiest way to check that is do show IP OSPF from the command line and make certain that all the interfaces that you want to be identified with the process are in fact listed. If one is missing, then for some reason or other something's been misconfigured, then you can execute the show running configuration command to verify that the network statements are correct. If the mask is a little more exclusive, you may fail to be able to identify a particular interface. And if that's the case, delete and recreate the network statements with the correct subnet and the correct mask combinations. Then execute show IP OSPF again, and you'll probably see that the problem has been corrected. Another possible cause, this is more along the lines of wide area networks, but it could be a non-broadcast network that you're dealing with. You can use the show IP OSPF interface command and discover the network type that's being used. If it's under the network type entry, specifically when you're looking, if it says non-broadcast in caps, as you see on the screen here, it means it's a non-broadcast type of network, and you need to make sure that you have manually configured your neighbor settings. You only have to do this on the hub device. For instance, if it's a multi-point frame relay network, you just need to do it on the primary hub device. If there are two, then you need to do the same thing and have it designated as a backup designated router, for example. But make sure the neighbor IP address command is present in the configuration. If the statement is missing, put it in on the whatever designated router, backup designated router you want, and make sure that the spokes have an IP OSPF priority 0 on the serial interfaces in this case in order to be able to form the neighborships correctly. Something else that can cause neighbor relationships not to form is what I just mentioned a moment ago, the priority 0 command. Execute show IP OSPF neighbor, and it will show you the configured priority of the neighbor. If, remember, all defaults are at 1, but if 0 has been configured on a particular device that you want to form a neighbor relationship, you want to be the designated router, for instance the hub site router, then you need to change that. Another thing that can cause it is mismatched timers, because OSPF again is very picky about this, just as it was with the MTU size. Do show IP OSPF interface, and it will show you the value of the timers under timer intervals, hello for the setting and dead for the setting. If the values don't match, actually go into the process of the interface and change it manually. IP OSPF timers. So aside from neighbor relationship problems, you can also run into expected routes being missing from the OSPF and IP routing tables. The first thing that you can do is make sure, cause number 1, that network commands have been correctly configured. Use show IP OSPF interface. See if all the expected interfaces are part of the process. You can also use show running configuration to actually look at the specific neighbor commands, make sure the masks are correct, make sure the IP address is correct, and delete and recreate the network statements if they're not there. Another thing that can result from misconfiguration has to do with the default route being misconfigured. On the device that is originating the default route, do show IP route and make sure there is a static route to network 0000 and that it's installed and it's valid and that it exists. When you do show IP route, if it's not valid, it won't be in the table. Then do a show running configuration. Verify that you have redistribute static under the OSPF process, and also the default information originate command, which is required. You can have the route redistributed and in the table, but if you don't do default information originate, it will not work. If these commands are missing, make sure you add them in. The third common group of problems typical in OSPF has to do with address summarization issues. And as with the case with EIGRP, it could be the reason a particular area range or summary address is not advertising the desired summarized address is because there are no subnets within that range existing in the IP routing or OSPF tables. The easiest way to verify this is do show IP route on the originating device to make sure that there are networks within that range that indeed are there. Make certain that interfaces haven't failed, that network commands have been properly configured, for example, on some of the other causes we've talked about. Make sure the range exists. Then execute the show running configuration command. Verify that the IP, whatever the area is, area range command with the correct mask and the correct subnet is there, or the summary address command, prefix mask, is present on the ASBR. Make sure they're there, make sure they're correctly configured, and even look for the summarized route to null 0 in the IP routing table. If it's incorrect for some reason, delete and recreate the summary statement with corrections, or find the cause of the missing route. Another common cause for address summarization issues is going to be resulting from the fact that that particular router may be residing in a stub or not so stubby area. Again, always make sure that the range you're trying to advertise has subnets existing in that range in the IP routing table. Do show IP route and make sure it's there. Additionally, execute the show IP OSPF statement and look for the specific phrase, it is a stub area. If that is the case, you're going to have the problems with summary routes because summary routes are naturally suppressed in stub, totally stubby, and not so stubby areas. So your choices are either to change the area type or just to verify the reachability of the area range or summary address. It may not be in the table, but you may be able to actually ping and get to it. in which case this is normal behavior for a stub area. It's critical within troubleshooting OSPF to understand the tools that are available to you. The best and most common tools to use are the commands show and debug. We're going to look at various ones in this particular section to better acquaint you with what they can show you. First, we're going to review show commands. As with EIGRP and practically any other protocol, the show IP protocols command can be particularly helpful. It will display your OSPF status and process ID. It will show the different area types are configured, normal, stub, NSSA, and so forth. It will show you any protocols that are being redistributed, what networks are being advertised, and neighbors or gateways. It's a much broader show command, but it's still extremely helpful. It can be very helpful in troubleshooting neighbor relationships, for example. For instance, if neighbors or gateways are missing that you're expecting, it'll be able to show you that. Missing routes, problems with summarization, and problems with filtering. Another helpful command is the show IP route OSPF command. It shows you the routes that are being received from neighbors, the administrative distance, the cumulative cost metric to reach a particular subnet, and whatever the route source and interface is. This can be helpful in troubleshooting missing routes, summarization issues, filtering problems, and also just general troubleshooting. Show IP OSPF interfaces is particularly helpful because it will show you all the interfaces that have been configured and are participating in OSPF, the network types, remember broadcast, non-broadcast, and so forth, the neighbor count, authentication types, and timer values. And it goes without saying that this can be helpful in troubleshooting neighbor relationships, local configuration issues, and routing problems. Show IP OSPF neighbors, helpful in figuring out local configuration issues and neighbor relationships. It will actually display active fully adjacent neighbors with their router IDs, their IP addresses and interfaces, the dead timers, and what the state is, full, xstart, and so forth. Remember, if anything's stuck in that particular state, anything other than full, then you know there might be an issue. It also shows the state of the designated router and backup designated router that it may be connected to. If it's the DR, it'll say, for instance, full/DR. If it's a backup designated router, it'll say full/BDR. And if it's just another device that's neither, it'll say full/DR other, meaning it is neither the DR or the BDR. The show IPS OSPF database command will show you the entire contents of the link state database. It'll show the LSA types per area, 1, 2, 3, 4, and 5, for example, the router that's advertising that particular network, the link ID, specifically the subnet, and the age that's in the routing table. It's helpful in troubleshooting missing routes, filtering problems, and general troubleshooting. Another command that's very specific to OSPF is the command show IP OSPF border routers. It shows the router ID, the advertising router, the area it belongs to, whether it's an area border router or an autonomous system boundary router. It'll actually list them all out, and the cost to reach them. This can be helpful in troubleshooting missing routes, filtering problems, and general troubleshooting. For instance, if an external router is missing, this would be one way to be able to tell you if something is awry with the ABR or ASBR. In this case, it'd be ASBR. And finally, another command that's very helpful is the show IP OSPF command. It shows the process ID, the configured areas, the number, types of areas, the ranges of those areas, configured area authentication. Something else that's helpful is it shows the number of times the SPF algorithm has been executed. If you look at a particular area and you see a very high number of SPF calculations, it could be a flapping router or an interface with an issue. It also shows you interfaces per area on the router. It's helpful for missing routes, filtering problems, and general troubleshooting. Debug commands can also be particularly helpful in determining cause of particular issues. The debug IP OSPF adjacency can help you with debugging neighbor adjacency issues. It's helpful in troubleshooting, obviously, neighbor relationships, routing update issues, LSA types, for example, and stub router problems. The debug IP OSPF events helps you debug network events. It'll show you the different things that are going on with the network from an OSPF standpoint. It can help you with routing, update issues, convergence issues, and interface flapping. And another thing that's helpful is the debug IP SPF hello. It helps you debug neighbor adjacencies. It shows how often the hellos are happening and what's involved with that. This can help you with troubleshooting neighbor relationships, configuration issues, and because the hellos are used for DR and BDR election, it can help you with those issues as well. Now that we've reviewed the different relevant debug and show commands, we actually want to demonstrate them in practice in our lab. Now we've already talked a little bit about our console that we use, Kiwi Cat Tools or SolarWinds Cat Tools as it's called now. You can see a number of our devices all summarized here. We want to look at router 6 because that's the designated router for the OSPF network on the wide area network. So we talked about show IP protocols. Now watch this. It lists the process ID. We're not looking at any filtering. There are only one areas designated. It's a normal area. In this case, it happens to be area 0. Look, it lists the router ID, 10.6.6.6. Here, routing for networks lists all of the networks that have been configured and what area they're a part of. Look, the loopback 0 has been passive interface. We'll correct that in a moment. And then the two other routers you would expect to see, router 8 and router 7, because 8 and 7. The administrative distance. So let's go into we'll look at the configuration. Notice here, passive interface loopback 0, which really won't matter a whole lot because it's not sending or receiving hellos because it really doesn't go anywhere. But let's go ahead and correct it. So router OSPF 1. Now we'll do no. Now when we'll do a write mem. Now we'll go back where show IP protocols. Notice now it's not listing loopback 0 as a passive interface. Now we can do show IP OSPF interface. See here the name of the interface, up, the configured address, the area that it's in, the network type. Here we have another one. Notice network type broadcast because it's on an Ethernet. We're going to go down and actually look at our serial interfaces. The serial interface, look, network type non-broadcast. The designated router is listed as this router. Notice here the hello, dead, and obviously wait, the different timers. Notice it's listed as the designated router at priority 1 because the default has not been changed. Shows neighbors, SPF count, and some of these other things for the show IP OSPF interfaces. Now we can do show IP OSPF neighbor. It lists the router ID of the neighbor. Notice here it says DR other because these particular routers, router 8 and router 7, are not designated routers or backup designated routers. The dead timers and the serial interface obviously identified. You show IP OSPF database, which lists the link state database. Notice it shows the router ID, but here we go, router link states. Remember that's LSA type 1, the link ID, the advertising router, and so forth. Network link states, LSA type 2, summary net link states, LSA type 3s. By area. Since everything's in area 0, everything's summarized here. So do show IP OSPF, do show IP route OSPF. Notice it lists, in this case it's OSPF inter-area routes because everything's been configured in other areas except for the additional interfaces on this particular device. And then finally show IP OSPF border routers. It lists routers 7 and 8 because both of them are ABRs. They are the gateways to other areas. So it shows the SPF calculation and it shows the router IDs, the interfaces that it's found on. And now, finally, do show IP OSPF, which lists a great deal of information on the OSPF process. Shows the areas, shows the number of LSA types, hold times for SPF. The area 0, interfaces in the area. Look how many times the SPF process has been calculated. And these are just some of, well, a great number, but some of the configuration verification commands that can be used in OSPF. Now, as is the case in dealing with EIGRP, you may have particular problems that come up that go beyond some of the steps that we've talked about. Something unusual or something that you can't quite pinpoint, in which case you'll need to open a Cisco Technical Assistance Center or TAC case. So we want to review a little bit about TAC, severity levels, how to open a case, information to have. We'll just quickly review this since we've been through this previously, but also TAC case etiquette. Now you may recall from our previous discussions, TAC gives you 24 by 7 by 365 coverage for whatever Cisco products you're owned, provided you have a valid service contract. The centers are located worldwide. There are a number of ones, but the primary sites are in San Jose, which is no surprise because that's where Cisco's based. Sydney, Australia, which I've had great experiences in TAC case with, love those guys. Raleigh, North Carolina on the East Coast, and then Brussels, Belgium. You must have a valid SmartNet service contract to open a TAC case. Now there are 4 levels, you may recall, of severity. S1 is what they call a network down emergency. There's a critical impact. The network is not operational, and both you and Cisco will commit 24 by 7 resources to resolve it. S2 is the network is severely degraded. It's operational, but it is operating at a much diminished capacity. There are significant impacts to aspects of your business, and you and Cisco will commit whatever necessary resources are, but normally during the 8 to 5 business day. Severity 3 is the network's up, the network's running, but it's impaired in some degree. It's not completely degraded, but it is impaired in some degree. Most operations are unaffected. You and Cisco are willing to work 8 to 5 in order to be able to restore service to normal operations. And severity 4 really isn't a severity level at all. It's just a request for information or configuration assistance in which there's no real impact to the network. Opening a TAC case, again, you can do it by email at tac@cisco.com. You can open it on the web. You go to cisco.com. You can go to the support section and literally open a TAC case. You can also open a case by phone in the different regions. There's some information you need to have when you call. Now, there are certain things that are nice to haves and others that are must-haves. For must-haves, you need to have your service contract number, your product or chassis serial number, which you should be able to easily obtain, the product model, the particular hardware configuration, for instance, what modules or interface cards are present, the physical location of the product, and whatever the severity level is. It's helpful if you can quickly summarize the issue, give it a descriptive title, describe the history of the problem, a little bit about the network that it's a part of, output from the show tech command, whatever other relevant output, software versions and types, and logs of anything that may have been going on in the network when it happened. Make sure you work the case actively, send updates, keep communication open, close it when it's resolved. And just some etiquette. Treat the engineers with courtesy and respect. They are people too. They're frequently under a lot of pressure to get things done, just as you are if there's, for instance, a network down emergency. Make sure you realize that they are not an extension of your staff. They're there to help you, but you need to be able to make sure that you have adequate help and personnel with the appropriate skill levels on staff. If there are separate issues, create separate TAC cases. Remember, you control the severity level. Escalate to the TAC duty manager if you're not getting the results you want. And when things go well and someone's done a great job, make sure you pass compliments along to that engineer supervisor. Bad news always seems to travel more than good news, so really make an effort to let good news prevail. Some key terms, obviously Cisco TAC, the Technical Assistance Center. Severity 1, network down emergency. Severity 2, network is severely degraded but operational. Severity 3, production network is impaired but mostly functional. And severity 4, requests for information or assistance. So we looked again in our lesson at the troubleshooting model. Common issues and resolution steps specific to OSPF, neighbor relationships, missing routes, summary routes, etc. Relevant debug and show commands, and finally dealing with Cisco TAC. Thank you for your kind attention, and we'll talk to you again soon.